Today we're going to be factoring trinomials in the form x squared plus bx plus c. So we have this trinomial, and there's going to be an x squared in the front. So our essential question is, what is the shortcut for factoring trinomials in the form x squared plus bx plus c? So before, you know that we multiplied two binomials together, and then what happens is you get something in this format. So for instance, you remember when we multiplied, like x plus 1 times x plus 2. Okay. When you multiply those out, you take x times x and x times 2. So we get x squared plus 2x. And then we took 1 times x and 1 times 2. So we get plus 1x plus 2 again. And then when we combine these terms, we got x squared plus 3x plus 2 as our final answer. So it looks like this right here. So there's a trick, okay? We see that when we multiply these two numbers out, that these two numbers in the middle have to add to be 3, and they also have to multiply to be 2. So there's a shortcut when we're factoring, when we're trying to go backwards and figure out what these two factors are. We just look and we see that these numbers have to multiply to be the last number, but they have to add to be the middle number. So we're finding two numbers that multiply to be the last term, and they add to be the middle term, just like we have here. They multiply 1 and 2, they multiply to be 2, and 1 and 2 add to be 3, because that's what we get when we're multiplying it out here. Okay? So we're going to factor x squared plus 7x plus 12. So remember, we're trying to get numbers that multiply to be the last term, and they have to add to be the middle term. Okay? So if we look, just think of all the numbers that you can that multiply to be 12. Okay, so if we think of all the factors of 12, we have 1 and 12, 2 and 6, and 3 and 4. And so you have to ask yourself, which numbers multiply to be 12, and then what do those numbers add to be? Okay, so if we try 1 and 12, that makes 13, so that doesn't work. If we try 2 and 6, that makes 8, so that doesn't work. But if we try 3 and 4, that makes 7. So those are going to be our numbers. So we just go back and we fill in those numbers into our two binomials. So we have x plus a number and x plus a number, and those numbers happen to be 3 and 4. And if we want to check this, we can actually multiply it out and see that it works. Okay, so if you want to check this, we're going to take x plus 3 times x plus 4. So we have to take the x times both numbers. So we get x squared plus x times 4 would be 4x. And then we take the 3 times both numbers. So 3 times x would be 3x. And then 3 times 4 would be 12. And when we combine our like terms, we get x squared plus 7x plus 12. So it works. Okay, the two numbers that we came up with, 3 and 4, they multiplied to be 12. And they added 3 and 4, they added to be 7. So it works out. Sorry. All right, let's try these trinomials then. We aren't going to make the whole chart for all of these, but I was just trying to show you guys how this works. So factoring g squared plus 7g plus 10. Okay, so remember, they have to multiply to be 10 and add to be 7. So I kind of always do a little chart like this. They have to multiply to be 10, but they have to add to be 7. So what multiplies to be 10? Well, we've got 1 and 10, but that doesn't work. 2 and 5. So if I plug in 2 and 5, that works. So I have 2 plus 5 equals 7. So my factors, when I plug them in, I plug in positive 2 and positive 5. And this would be my answer. And if you want to check, you can multiply it. So g times g would be g squared. G times 5 would be 5g. 2 times g would be 2g, but when I add 5g plus 2g, I get 7g. And then 2 times 5 would be 10, so it works. Okay, let's try another one. And feel free to pause the video at any time and try these on your own and then check and see if you got it right. So we've got, they have to multiply to be 20, and they have to add to be 21. So we're going to set up our trinomials. We've got v and v, because v times v gives us the v squared. Okay, what numbers multiply to be 20, but add to equal 21? So 20, I've got 1 and 20. Oh, there we go. So 1 and 20. So v plus 1 and v plus 20. Now you might be asking, does it matter what order I put these in? Does the 20 have to come first, or does the 1 have to come first? Well, when you're multiplying numbers, it doesn't matter the order, because if you take 1 times 20, it equals 21, and so does 20 times 1. So the order really does not matter. Okay, last one. A squared plus 13a plus 30. So we're finding factors of 30 that add to be the middle term, which is 13. Okay?
Orange.
Alright, so we've got factors of 30 that add to equal 13. So we've got 1 and 30, that doesn't work. 2 and 15, that doesn't work. 3 and 10. So we have our binomials, and we have a plus 3 and a plus 10. So a times a is a squared, a times 10 is 10a, 3 times a is 3a, so if we add the 10a plus the 3a, we get our 13a, and then 3 times 10 would give us 30. Alright, now those were all positive ones, but let's try what happens when we get some negatives. Alright, so we're going to factor d squared minus 17d plus 42. Well, we're going to follow the same pattern that we've always been following. We still want our numbers to multiply to be 42, but this time we have a negative in here. We want them to be negative 17. So how is it possible to get two numbers to multiply to be a positive number, but they add to be a negative number? Well, both of the numbers would have to be negative, because a negative times a negative is a positive, but a negative plus a negative is a negative. So we have to find two negative numbers that multiply to be 42, but add to be negative 17. Okay, so both numbers must be negative. So let's try our factors of 42. Well, both of them have to be negative. I could have negative 1 and negative 42, but when I add those together, I get negative 43, so that doesn't work. I've got negative 2 and negative 21. But when I add those together, those equal negative 23, so that doesn't work. Okay, negative 3 and negative 14, and there we go. We have our negative 17. So if you're not sure what numbers to use, just take your calculator and start taking your number and dividing it by other numbers to see what works. You can do some guessing and checking. Okay, so since negative 3 and negative 14 were our two magic numbers, when we put those into our binomial, we have a negative 3 and a negative 14. So both of them need to be minus. All right, let's try some more examples of those that you guys can try on your own. So we've got k squared minus 10k plus 25. So this time our numbers have to multiply to be 25, but I want them to add to be negative 10. Okay, so let's think of what I can multiply to be positive 25, but add to be negative 10. So again, both my numbers are going to have to be negative. So I've got negative 1 and negative 25. That doesn't work. And so the only other numbers that multiply to be 25 would be negative 5 and negative 5. So I would write my binomials as k minus 5 times k minus 5. All right, let's try some more. So we've got 18. We have to multiply to be 18, but they have to add to be negative 11. So again, the two numbers have to multiply to be a positive, but add to be a negative. So both of my numbers are going to be negative again. So let's see, what multiplies to be 18? I could have negative 1 and negative 18, but that wouldn't work. Negative 2 and negative 9. There we go. So we have x minus 2 and x minus 9. All right, last one. We have numbers that multiply to be 36, but add to be negative 15. Okay, so 36, I can do negative 1 and negative 36. I can do negative 2 and negative 18. I could do negative 3 and negative 12. That would work. So I have q minus 3 and q minus 12. Perfect. All right, there's one different kind, one more type that we can try to factor. Let's look at that. Okay, what happens when the last term, c, when this one is negative? Well, we have two numbers that multiply to be a negative number. Now, how is that possible? Okay, I can't do both positive because that would be a positive, and I can't do both negative because that would multiply to be a positive. So that means that I'm going to have one number that's negative and one number that's positive. Okay, so we're thinking of factors of negative 27 that add to be a positive 6. So this is where it gets a little tricky. Okay, I could do positive 1 and negative 27, but that gives me negative 26. Or I could flip it, and I could do a positive 27 and a negative 1, but that gives me positive 26, so that doesn't work. So then, let's try multiplying 3 and negative 9. That gives me a negative 6 when I add those together. So I need to flip it. I need to do a positive 9 and a negative 3, so that works. So, again, if you're confused about what to do, then just keep trying a mixture of numbers or like flipping the negative sign and seeing if that works. Okay, so let's try this. So we had positive 9 and a negative 3. So one factor was a plus and one factor was a minus. All right, so negative 3 in the middle and negative 18 on the end. So we're trying to come up with numbers that multiply to be a negative 18, but add to equal a negative 3. So one number has to be positive and one number has to be negative because they multiply to be a negative number. All right, so we could try positive 1 and negative 18. That doesn't work. We could flip it and we can do positive 18 and negative 1, but then that just makes a positive 17. So we need to try different numbers. So what else multiplies to be negative 18? I could do 2 and 9 and make one of them negative. Or I could do 6 and 3 and make one of them negative. So negative 6 and positive 3 would work. So my factors would be, since it was positive 3 and negative 6, the 6 would have to be negative, so p minus 6, and the 3 would have to be positive, p plus 3. All right, let's try a few examples on our own then. So what multiplies to be a negative 20, but adds to be a positive 8? So we've got 1 and 20. We've got 2 and 10. If I do 2 and 10, which one would have to be negative to make a positive 8? It would have to be the 2. So we've got m minus 2 and m plus 10. All right, let's try the next one. So we've got p squared minus 3p minus 40. So we're coming up with factors of negative 40 that add to be negative 3. So I can do 1 and 40, 2 and 20, 4 and 10, 5 and 8. So if I do 5 and 8, those have a difference of 3. And which one would have to be negative to make a negative 3? Oh, the 8 would. So I would have p plus 5 and p minus 8. Alrighty, last one, and then we're done. This one's kind of tricky. So we've got factors of negative 56. But when I multiply them, what number is in front of this middle term? There's actually a 1 there. So they have to add to be a negative 1. So this one's kind of tricky. So there's all kinds of numbers you can multiply to get negative 56. We could do 56 and 1. And then you might try on your calculator and try a few others to see which ones work. But I know that 8 and 7 multiply to be 56, and those are one number apart. So I know it's going to be 7 and 8, but which one would have to be negative to come up with a negative 1? It would have to be the 8. So we've got y plus 7 and y minus 8. So in summary, how are you factoring these trinomials? What is your pattern?